So as I mentioned, right, we know how to differentiate something like sine of x. We know how to differentiate something like x squared minus 4. But what if we have the composite function? So if this was f of x and this was g of x, and I wanted to create f of g of x, right? That would be sine of x squared minus 4. That we don't know how to differentiate. We don't know how to take a derivative of that one. But we will today using the chain rule, right? And this chain rule, it has got to be everybody's favorite. It's definitely like if I have to rate everything that we do in math, this would definitely be like one of the ones way up here. All right?
Yeah.
Huh?
Like top 5.
Top 2? Maybe. Yeah. No, definitely. Yeah, top 5. So here's what the chain rule is. Okay? Suppose f is differentiable at the point u, right? If f is made up of f of g of x, then what I do, if I want to take a derivative of f of g prime, right? If I want to take a derivative of f of g of x, what I do is I take a derivative of f, and then I take a derivative of g. So my composite function is sine of x squared minus 4. If I want to take a derivative of this entire thing, you know how we composed it out of 2 different functions? So first, on the one hand, you have the sine, and then you have the x squared minus 4. So what I do is I take a derivative of the sine times the derivative of the inside. Okay?
So would both of them be the
Together, there would be, sine of x squared minus 4, that's f of g of x.
Yeah, so you
Now,
need to separate the derivative of just sine.
yeah, its derivative is going to be the derivative of the sine times the derivative of the inside. Okay? All right. So Leibniz, you know, he's the other guy besides Newton who invented calculus. He says if y is equal to f of u and u is equal to g of x, then we take a derivative of f times a derivative of g. Okay? All right. So let's take a look at this one. Take a look here. So basically what we're going to do is we're going to have an f, and then inside we're going to have a u, right? So we're going to write our functions as f of u, where u is the second function, all right? So my function is going to be f of u, and u is going to be the second function, g of x, correct? Okay? All right, so here, y is equal to cosine of x squared minus 1. U is this one, okay? So what we're going to do now is we're going to find y prime. First, we have to take a derivative of f of u. What is f of u? What function is it? It's a cosine, right? So if I take a derivative of cosine of x squared minus 1, what will I get? Negative sine of x squared minus 1. So remember, this is f of u. It's not cosine of x. It's cosine of u, x squared minus 1. So the derivative will be, okay, f prime of u. So if it's cosine of x squared minus 1, the derivative will be negative sine of x squared minus 1. Okay, yes?
Do you not separate like before you were
No. Well, now, right, so now this is just half of it. Now we have to do the other part.
Oh.
Yeah.
Wouldn't it be negative sine x 2?
Huh?
Wouldn't it be negative sine x 2?
Negative sine x squared? No. Because first what you do is you have to take a derivative of the cosine, right?
Why can't you just do it all at once?
You can't. Well, that would not be the chain rule. That would be something else that you just invented. Right? That would not be the chain rule. Right. That would not be the chain rule. That would be something else. So I'm not done with this one yet.
Okay.
This is just the first part. So first I'm going to take the derivative of the cosine, but cosine of what? of whatever I'm given, x squared minus 1. Now, times, now I need to take a derivative of u. What is u? This is u, and the derivative of it is 2x. Now we're done. So now I can write y prime as I have to, I write it in a more cleaner format. So it'll be negative 2x sine x squared minus 1. Okay, now let's do another one. We have sine of root x. All right, so we have two functions here. We have a sine, and then inside the sine we have a what? A root x. So a good way to think about these is there is an outer function and an inner function. There is an outside function and an inside function. What is the outside function? It's the sine, and the inner function is the root x. So now I'm going to take y prime. First, I'm going to take a derivative of the outer function, which is what? Cosine. Cosine of what, though? Root x. Times. Okay. Now, how do we do root x?
You take the 1 and you put it in front of the x. Oh, and then the x.
Isn't it 1 over 2x?
Okay, so what is root x really? Root x is x to the power of 1 over 2. Is that right? So now, ddx of x to the power of 1/2 is, the 1/2 comes down, and it's x to the power of 1 over 2 minus 1. So this is 1 over 2 x to the what? Negative half. Because what is the power rule? The power rule is if you have x squared, the 2 comes down and you subtract 1 from the exponent. Okay? Now.
Why don't you just put negative 1/2?
Why
don't you just put to the power of negative 1/2?
I just did that. Half x to the power of negative 1/2. So now this is going to be then 1/2 x to the power of negative 1/2. Okay? But now, it doesn't look good, right? We don't like the way that looks. So, why don't we write this? There is a fraction, right? Because we have a 2 underneath. On top, what do I have? I have cosine root x. Now, what about that pesky x to the negative 1/2? What is it? Can you put it in the, where? In the denominator? Can we put it in the denominator? Yeah, because that's what we do with negative exponents. I can take x to the negative 1/2 and put it in the denominator, but that still doesn't look very good. So I could say, this is y prime, cosine root x over 2 times root x. Okay? Yes, so let's think about that one more time. So what we got was 1/2 x to the 1/2, a negative 1/2, which means it's 1/2, and the x to the negative 1/2 is going to move down, right? So it's going to be down here, x to the half, which will be 1 over 2 root x, right? So we have a 2 on the bottom from here. It's 1 over 2. That's at the bottom. Now the x also moves to the bottom, so we can make it a positive exponent, and it'll be 1 over 2 root x. Now, if going forward, eventually going forward, you're going to just know 3 months from now that the derivative of root x is 1 over 2 root x. You can either know that now, or you can go through the process and still come at the right answer. Question? Yeah.
Can you explain one more time why it goes why the root x goes to the bottom? Is it because it's part of the 1/2 x?
It's because here we had x with a negative 1/2. Whenever you have a negative exponent, if it's in the top, it goes to the bottom. If it's in the bottom, it goes to the top. Okay? So because it was x to the negative 1/2, we moved it down and we made it x to the positive 1/2. And x to the half is just root x.
So if it was positive 1/2, it would go to the top?
If it was positive 1/2, yeah, it would just stay on the top. It would just be root x on top. Okay? All right. So take a look here. An object moves along the x-axis so that its position is given by x of t. So this is position. And that's a nice composite function with a cosine in there, right? It says to find the velocity as a function of t. So when you have velocity, it's instantaneous velocity. So what are we going to do? Take the derivative, right? So velocity is x prime of t. So that's going to be, all right, what's the outer function here? Cosine. So when I take the derivative, it'll be negative sine of what? Correct. Times, what's the inner function? Right, it's t squared plus 1, and the derivative will be 2t. So v of t? Correct. So that's the velocity as a function of t. It's the exact same thing because look at how similar the functions are. One is cosine x squared minus 1, one is cosine t squared plus 1. Yeah. Yeah.
Why don't we have to do the product rule?
Sorry?
Why don't we have to do the product?
Because this is not a product. This is one function. You don't have a cosine times another function. You have a cosine of another function. All right? Common mistakes that students make. One is here, when they take a derivative of the cosine, they'll just say it's negative sine t and not copy the t squared plus 1, not copy the u over. That's the most common mistake. Second most common mistake is students will think that this is cosine x times x squared plus 1, so they start doing a product rule. So if you are just careful about those two, when you get a problem, ask yourself, is it product or chain rule? And when you've determined that it's a chain rule, then always be mindful that you do f prime of u, okay? The sine of t squared plus 1. This is still like a very simple case. Things can get all sorts of funky, okay? Yeah.
If it was product rule, it would be like sine x, like you'd see it.
Yeah, it would be cosine t times t squared plus 1. You know? Yeah. Okay. And like there are problems where you have a chain rule within a product rule. Okay? Those are really cool. All right. So outside, inside, like we've been talking about, what we do again is first you take a derivative of the outside function and then multiply it by the derivative of the inside function. Okay? So here's what we're going to do. That's what we're going to do here. So here we have cosine of 3x. What's the outside function? Cosine. And what's the inside function? 3x. Okay, so right now, take a moment and go ahead and find the derivative of this, y prime. All right, raise your hand if you're willing to give me an answer here. Yes. Negative 3 sine 3x. Awesome. All right. Anybody wanna attempt part B? How about somebody come up to the board and do part B? You want to do part B on the board? Go ahead. Take a pen over there or this one. I'm over here.
It's the same rule.
It's the same. It's the same thing. I just in the box. It's the same thing. Rather than saying like in the Leibniz notation, now I'm just telling it to you in like layman notation with outside and inner.
Outside, inside rule and chain rule.
Right. All right, what do we think? Would anybody?
Wouldn't the X change into a 1?
Huh?
Wouldn't the X change into a 1?
The numbers there and the symbols are all correct. What about a parenthesis?
In the beginning, so you know you're signing it, not just signing it by 1.
You're multiplying it, right? So there are parentheses around the 2x plus 1. Okay, that makes all the difference because
Because then you just multiply 1 to cosine.
right, it's 2x plus 1 times the cosine, not 2x plus 1 times the cosine. Okay. First, you take a derivative of the sine, and it's cosine. Yes, and then you have to take a derivative of everything that's inside the parentheses, not just the cosine. Okay. Next. So let's do the next one. What if you have to do in one problem, you have to do the chain rule more than once? Oh my. So what if it's not f of g of x? What if it's f of g of h of x? Okay? Oh my. Okay. It's all sorts of fun. Okay. So, we're going to take a derivative of this. Okay, let's just see here. What is the outermost function? Tangent. So here we have an outside function. What's the inside function? Oh, it's 5 minus, the inside function is 5 minus sine 2t. But even there, it's sine of 2t. Okay? So we have 5 minus sine. 5 minus sine, that's the second function. And then 2t, that's the third function. So we start from the very outside. And I like to color code this as much as we can. So the very outside function is what? Tangent. And it'll be secant squared x. So this is going to be secant squared of what? Of 5
minus sine 2t.
Right, of everything. So let me repeat that. It's tangent of all of this. So when you take a derivative, it'll be secant squared of all of this. Okay?
And then for the next one, we find the derivative. We leave secant squared of this, or do we find the derivative of secant?
Okay. Huh? No. Secant squared as it is because that's already a derivative.
Right, okay.
Yeah.
I didn't know we had to find the derivative.
No. Now, okay, so basically, here's what I like to do. I did the tangent, right? I'm done with the tangent. Now, I need to take, or I'm going to do it now. So now it's going to be times the derivative of the second function, which is 5 minus sine. Okay, so what'll that be? The derivative of 5 is 0. And then negative cosine of what? 2t.
Is it really positive cosine though? Because it's negative sine. So it doesn't-
No, the derivative of
Oh, no,
sine.
I'm
Yeah.
confused.
Okay. So now we got rid of the blue one as well. Now we need to take a derivative of 2t, which is 2. Okay, so let's think about that again. The first function was tangent, and we took a derivative of that in the purple. Okay? Tangent of that whole mess, the derivative is secant squared of that whole mess. Now, the next function was 5 minus sine of blah. I took a derivative of that. It's 0 minus cosine of blah. Then, it's the derivative of the very inner, the blah, which is 2. Okay? And I like to, as I'm going along, cross out the ones of which I took a derivative so as not to repeat them. Now we just have to write that in a more elegant form.
So 2 secant squared.
Right, and the negative outs will come out too. So negative 2 secant squared 5 minus sine 2t times cosine 2t.
If you kept the negative with the cosine instead of the front, would that make a difference?
It wouldn't make a difference. It's just convention that we put all the constants and the negatives outside in the front.
Well, negative sine 2t.
Huh?
Well, negative sine 2t.
Well, that's in the secant. It's 5 minus sine 2t. That's all together. It's one package together. All right?
Yeah.
Okay. So let's do a little bit more. Power rule, right? Same situation. The power comes down, and then you have to take a derivative of what's inside. So for example, if you have x squared plus 1 to the power of 3, and you want to take a derivative of this, right? Then what would happen? Where would the 3 go? In the front. So you have 3 times x squared plus 1, okay, times what? Times 2x. Okay, shall we do another one like that? Yes, let's do another one like that. What if I want to take a derivative of 2x cubed minus 3 to the power of, oh, let's say 4. The 4 will come down, and it'll be 4 times this, times what? 6x squared. Okay? Yeah. So take a look at this one. Now we have a root tangent, but there is no exponent. What do? Yeah. To the power of 1/2. Right. So y is tangent 5x to the power of 1/2. Okay. Now, y prime, what's going to happen to the 1/2? It's going to come to the front. So it's going to be tangent 5x to the power of what? Negative 1/2. Okay, so remember what, I'll get your question in a second then. So remember what the power rule says. Look up here. Exponent, well, let's do this one. Exponent comes down, oh, that should have a 2.
Yeah, that's what I'm saying.
Sorry, that should have a 2. And here that should have a 3. Oh my, okay. So,
Okay, that makes sense.
yeah, exponent comes down, we subtract 1. Exponent comes down, we subtract 1. Here, the 1/2 comes down, you subtract 1, you get a negative 1/2. Okay? Yeah? Was that your question, Zach?
Yeah.
What was your question?
Why is it times 6x squared?
Because once you take care of the power, you then have to take a derivative of the inside.
Oh.
Okay? So here, we took care of the power. Now we have to take a derivative of the inside. What is the inside? It's it's secant squared 5x times what now? There is another function that we have to take a derivative of, 5.
Oh,
Okay? All right, shall we go through that again? Yeah. Okay. Huh? Yeah, that's the final answer.
To the 1/2, is it always going to be, like, when you put the power rule,
Uh-huh.
it's always going to be a negative 1/2 of x?
So what did we do here? First, we had to take care of the power, right? Here. We brought the power down and then we subtracted 1. Next, we had to take care of the tangent here. All right, derivative of tangent is secant squared of the mess. Next, we now have to take a derivative of the very inside, which is that. Okay, so this will be 5/2. Now, we have to write it in a more algebraically correct form. You see how we have a negative exponent for the tangent? That's not allowed. Now, exponent of a half is root. But if it's negative a half, where is that root? On the bottom. So it's going to be the square root of tangent 5x here. Where does the secant go? Top or bottom? Top. Good?
Wait,
Yeah.
I don't understand. Why did you bring the root to the bottom?
Because it was tangent 5x to the power of negative 1/2. Here. You see there's a negative 1/2 there.
Right.
Negative exponents means if they're on top, they got to go to the bottom. If they're on the bottom, they got to go to the top. So the fact that it's a half means it's a root. The fact that it's a negative half means it's a root on the bottom.
Right.
Okay?
And then. Okay.
Okay? Yeah. Yes.
Where did the 1/2 come from?
The 1/2, which 1/2? This first 1/2 or the second one?
Yeah.
This 1/2?
Yeah.
Okay, you had a root?
Oh, and you're getting rid of the root?
Yeah.
Okay.
Okay.
And the second one is just you moving it to the front.
Uh-huh. Okay, let's do this next one. Y prime. Okay, so let's see how many different functions there are here. There is one function here with the power. There is a second function here with the 1 plus cosine. And then the 2x is the third function. So let's do the first one first. The 2 will come down. So it's 1 plus cosine 2x to the power of what? 1. Okay, now I need to take a derivative of the blue one, of 1 plus cosine. So it'll be negative sine 2x, thank you. And then times 2. Awesome.
With the exception of the last and the third one that you're doing, you have to include all of the other ones before it.
Yes. You do, yeah, just so it's cleaner. So this time I'm even going to move the sign out front, and that's just preference.
But it's not wrong if you do it in, so it's not confusing.
Right, just move the negative 4 out front. Okay. They multiplied, yeah, 2 times 2 became negative 4. Okay, now. Yes. Huh? Yeah. Okay. Oh my, look at, yeah, it is. Why is it confusing though?
Because it's like you have so many things to do.
Right. What do you have there? You have an x cubed times the 2x minus 5. So this is a product rule within which there is a chain rule. Oh yes. Okay. Okay. So now this is U. This is V. Okay? Okay. What is the rule? It's UV prime plus U prime V. Okay, so now let's just take it slow. Don't try to do it all in one step. Let's take it slow. In the product rule, eventually we're going to need the derivative of U and the derivative of V. So why don't we divide and conquer? First, here, let's take a derivative of U prime. What would that be? 3x squared. Okay, that we could do. What about V prime? Now that's the derivative of this. So the 4 will come down.
4 times
Uh-huh.
2x minus 5.
5 to the third
Uh-huh. Times
times 2.
2. Okay, awesome. That means it's 8 2x minus 5 cubed.
Also, in finding V prime, you have to use the power.
The chain rule. Yeah, yes. Right.
Okay.
Okay. Now y prime, now y prime is going to be uv prime plus u prime v. So y prime is equal to, now you just have to be careful of plugging in the correct elements. What was u?
X to the third.
X cubed. And what was u prime? I'm sorry, v prime?
8 times 2 times 5.
Okay, plus what was u prime? And v? Okay, now you just have to make sure, you just do all the multiplying. So let's do that. Oh my gosh, I just fell in love with this problem all over again. So, okay, now take a look here. Okay, take a look at the first term and the second term. Is there anything that is in common? You have an x cubed here and an x squared here. Can we factor out an x squared? Yeah, let's factor out an x squared. What else can you factor out? Okay, look, 2x minus 5, 2x minus 5. How many can we factor out? All 3, yes. So we are also going to factor out 2x minus 5 cubed. So now let's see what we're going to have left. From the, this way? Like that? Okay. Oh, that way. Okay. So from the first term, if we factor out an x squared and a 2x minus 5 cubed, what do I have left? An 8x. Plus, from there, what do I have left? A 3 times 2x minus 5. So this is x squared 2x minus 5 cubed times 8x plus, I'm going to go ahead and distribute the 3. You do, because look at what will happen now. More things will combine. X squared 2x minus 5 cubed times 14x minus 15. Tell me that is not the most amazing thing you've ever seen in your life. Right? Look at that. That's so awesome. That's so satisfying. Okay? Now, what's happening with the second one? What are we going to use for the second one? Quotient rule. So, what you're going to do is, again, low, high, D. Sorry. So same situation. Let's say this is U and this is V. Take U prime and take V prime, and then we'll do our low, D, high. Right. Yeah. Okay. So what's U prime? 1. Okay. Let's write V separately here. V is what? It's 1 plus 2x to the power of 1/2. So now V prime will be 1/2 times what? To the negative 1/2. Okay. Now, oh, we're out of time. Okay. Let me tell you which part of this to do for homework, because I won't see you again until Monday. So, on haiku, you will see that I have said on haiku that for Monday, assignment 3.6 part 1 is going to be due, right? So I would like you to do all the ones until number 29. Okay, so this is part 1. and it's due Monday.
Can we like turn in this assignment, or are we gonna turn it in as 2 different assignments?
Including, you're gonna turn it in as one, but I am going to check that you've completed up to 29 on Monday.
Wait, so
Okay.
is that including 29?
Yes.